What is physics? Physics is a basic discipline in the category of natural sciences, which also includes other disciplines like chemistry and biology. The word physics comes from a Greek word meaning nature. Its Sanskrit equivalent is bhautiki, that is used to refer to the study of the physical world. We can broadly describe physics as a study of the basic laws of nature and their manifestation in different natural phenomena. The scope of physics is described briefly in the later section. Here we remark on two principal thrusts in physics: unification and reduction. In physics, we attempt to explain diverse physical phenomena in terms of a few concepts and laws. The effort is to see the physical world as manifestation of some universal laws in different domains and conditions. For example, the same law of gravitation given by Newton describes the fall of an apple to the ground, the motion of the moon around the earth, and the motion of planets around the sun. Similarly, the basic laws of electromagnetism, that is, Maxwell's equations, govern all electric and magnetic phenomena. The attempts to unify fundamental forces of nature reflect this same quest for unification. A related effort is to derive the properties of a bigger, more complex system from the properties and interactions of its constituent, simpler parts. This approach is called reductionism and is at the heart of physics. For example, the subject of thermodynamics, developed in the 19th century, deals with bulk systems in terms of macroscopic quantities such as temperature, internal energy, entropy, etc. Subsequently, the subjects of kinetic theory and statistical mechanics interpreted these quantities in terms of the properties of the molecular constituents of the bulk system. In particular, the temperature was seen to be related to the average kinetic energy of molecules of the system. We get some idea of the scope of physics by looking at its various subdisciplines. Basically, there are two domains of interest: macroscopic and microscopic. The macroscopic domain includes phenomena at the laboratory, terrestrial, and astronomical scales. The microscopic domain includes atomic, molecular, and nuclear phenomena. Classical physics deals mainly with macroscopic phenomena and includes subjects like mechanics, electrodynamics, optics, and thermodynamics. Mechanics, founded on Newton's laws of motion and the law of gravitation, is concerned with the motion or equilibrium of particles, rigid and deformable bodies, and general systems of particles. The propulsion of a rocket by a jet of ejecting gases propagation of water waves or sound waves in air, the equilibrium of a bent rod under a load, etc. are problems of mechanics. Electrodynamics deals with electric and magnetic phenomena associated with charged and magnetic bodies. Its basic laws were given by Coulomb, Oersted and Ampere and Faraday, and encapsulated by Maxwell in his famous set of equations. The motion of a current-carrying conductor in a magnetic field, the response of a circuit to an AC voltage, that is signal, the working of an antenna, the propagation of radio waves in the ionosphere, etc. are problems of electrodynamics. Optics deals with the phenomena involving light. The working of telescopes and microscopes, colors exhibited by thin films, etc. are topics in optics. Thermodynamics, in contrast to mechanics, does not deal with the motion of bodies as a whole. Rather, it deals with systems in macroscopic equilibrium and is concerned with changes in internal energy, temperature, entropy, etc. of the system through external work and transfer of heat. The efficiency of heat engines and refrigerators, the direction of a physical or chemical process, etc. are problems of interest in thermodynamics. The microscopic domain of physics deals with the constitution and structure of matter at the minute scales of atoms and nuclei, and even lower scales of length, and their interaction with different probes such as electrons, photons, and other elementary particles. Classical physics is inadequate to handle this domain, and quantum theory is currently accepted as the proper framework for explaining microscopic phenomena. Overall, the edifice of physics is beautiful and imposing, and you will appreciate it more as you pursue the subject. You can now see that the scope of physics is truly vast. You can now see that the scope of physics is truly vast. It covers a tremendous range of magnitude of physical quantities like length, mass, time, energy, etc. At one end, it studies phenomena at the very small scale of length, 10 raised to the power minus 14 meter or even less, involving electrons, protons, etc. At the other end, it deals with astronomical phenomena at the scale of galaxies or even the entire universe, whose extent is of the order 10 raised to the power 26 meters. The two length scales differ by a factor of 10 raised to the power 40 or even more. The range of time scales can be obtained by dividing the length scales by the speed of light, that is 10 raised to the power minus 22 second to 10 raised to the power 18 seconds. The range of masses goes from, say, 10 raised to the power minus 30 kg, mass of an electron, to 10 raised to the power 55 kg, that is, mass of known, observable universe. Terrestrial phenomena lie somewhere in the middle of this range. Physics: Importance and Scope. Physics is the branch of science that deals with the study of natural phenomena in terms of basic laws and physical quantities. The word physics is derived from the Greek word physis, meaning nature or a part of the natural environment. The scope of physics can be divided into two major domains that are macroscopic and microscopic. The macroscopic domain deals with phenomena at laboratory, realistic, catastrophic, and astronomical scale. Whereas the microscopic domain deals with molecular, atomic, and nuclear phenomena. In our study of physics, we will look at microscopic phenomena under classical physics that includes mechanics, electrodynamics, optics, and thermodynamics. In physics, we attempt to explain various physical phenomena in terms of few concepts and laws. We see the physical world as manifestation of some universal laws in different domains and with the required conditions applicable as per the contexts. For example, the law of gravitation, which describes the motion of an apple detached from a tree which eventually falls to the earth, also explains the nature of the forces between Earth and the Moon, and also the forces that bounce the planet in the solar system in their orbits and keeps them in motion in their paths. Thus, we derive the properties of bigger or more complex system from the properties or interaction of the similar parts or constituents of the system. This approach is called reductionism and helps in understanding the properties of complex systems in physics, like functioning of satellites, etc. Physics is closely connected to technology and society. Most of the modern technologies are contributions from the realm of physics and work on one or the other scientific principle. Here are some of such technologies. These contributions came from all over the world. Here is a list of some notable physicists. These contributions came through observations, experimentation, or analysis of natural phenomena, and the realms or laws that govern such phenomena. These gave us the knowledge of fundamental forces in nature and physical laws. There are 4 fundamental forces of nature, and all other forces we know are derived from these forces. These fundamental forces are gravitational force, electromagnetic force, weak nuclear force, and strong nuclear force. The gravitational force is the force of neutral attraction between any two objects by virtue of their masses. It is a universal force, meaning all objects in the universe exert a gravitational force on each other. We are able to stand or walk due to Earth's gravitational force exerted on us by the Earth. Exerted on us by the Earth. Electromagnetic force is the force between two charged particles. Like charged particles repel each other and unlike charged particles attract. Like gravitational force, electromagnetic force is also universal and can act over very large distances. We do not usually encounter this force on Earth, as most of the matter around us is electrically neutral. Hence, of the two forces, gravitational forces dominate all terrestrial phenomena. An
An atom consists of three subatomic particles, namely electron, proton, and neutron. The force that binds protons and neutrons is a strong nuclear force. Weak nuclear force comes into existence in case of beta decay of the nucleus. In beta decay, the nucleus emits an electron and an uncharged particle called neutrino. Apart from finding the facts in observations and experiments, physicists always try to summarize these facts as laws or empirical relations in form of mathematical equations. These are known as physical laws. Most of these laws are based on some special quantities that remain unchanged in a process, which are known as convert quantities. Some of the general conservation laws in nature include the law of conservation of mass, energy, linear momentum, angular momentum, charge, parity, etc.